So here's the video solutions for the practice on scientific notation 1 through 13. Okay, the U.S. produces 4.34 times 10 to the 50 metric tons of wheat each year. Express that number in standard notation. So we use scientific notation when we have very, very, very large numbers or very, 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 very small numbers. So obviously in science we have a lot of those numbers. So that's why it's called scientific notation. Notation is a certain way we write stuff. So you learned way back in about October, maybe November, that if we have a number in scientific notation, that our job is to take this decimal and move it either to the right or to the left based on that exponent. If the exponent is positive, we move to the right. If the exponent is negative, we move to the left, and however many spaces that is. Because our system is base 10. So this just means every 10 is another place. Every 10 is another place. 10 ones makes $10 bill, 10 hundreds makes $100 bill, 10 hundreds makes 1,000, and so forth. So I'm simply going to take my decimal and move it 5 places to the right. Now I'm going to do a little shortcut. 1, 2, which means I'd have how many more zeros? 3. And then I'm going to write that number appropriately with the comma. So 434,000. Easy stuff. Number 2, the number 6.9 times 10 to the 6th written in standard notation is, so that's the same type of problem we just had. So I'm going to take that number and I'm going to move the decimal 6 places to the right. So I move it once. How many more zeros do I have to go? 5. 1, 2, 3, 4, 5. Put your commas in the right place and then rewrite it appropriately. 6,900,000. Basically, we use scientific notation when we have lots of zeros. Either zeros at the end of a large number or zeros in our decimals. 3. A certain bacterium has a radius of 2.5 times 10 to the second negative 7 meters. What is another way to express this number? Well, obviously, scientific notation. So I'm going to take that number. And this time, which way am I going to move the decimal? Left. So if I go 1 place to the left, how many more do I have to go? 6. So I put 6 zeros. And then I put my decimal there. A common mistake is kids don't move the decimal. And then I put a 0 in front of the decimal. So when I rewrite it, it would be 0.000000025, which ends up being tens, hundreds, thousands, okay? 10 thousands, 100 thousands, millions, 10 millions, 100 millions, 2,500 millions is how we read that. Number 4, what is the value of the number that is 10 times as large as this? Write your answer in scientific notation. So there's 2 ways to do this. 1, simply take this number, put it into standard form, and then make it 10 times larger. So multiply by 10. So that would be 3.4. I go over 1, so I have 5 more zeros. Okay, so that's going to be 3400000. And then 10 times as large would be multiplying by 10. Okay, so I have 0. Now I have 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 4, and 3. And then what does it tell me I have to write the answer is? All right, so remember we put the decimal between the first 2 natural numbers, so this is between 1 and 10. All right, so I have 3.4. Then I'm going to multiply by a power of 10. Well, this is where my decimal was. That's where I just moved it. How many places is that? 7. So 10 to the 7th. Now, another way to do this is, if I simply look at 3.4 times 10 to the 6th, and I multiply by 10, when you were in elementary school, I think, about 4th or 5th grade, and you multiply by 10, what did the teacher tell you as a shortcut? What can you do to a number if I multiply by 10? Either add or take away 0. Essentially what you're doing is you're moving a decimal, but you might not have had decimals in elementary school. Now we move decimals. Well, isn't this the part that tells me I'm going to move the decimal? Yeah. So if I'm moving the decimal 6 places to the right now, and yet my number is going to be 10 times larger, 10 times larger means another 10, right? Or one more jump. So really, this would be 3.4 times 10 to the 7th. When I multiply by 10, I just have one more jump. Or another way to do this is, let's say I take the 3.4 and multiply by 10. So that's going to be 34. And then 34 times 10 to the 6th, except for we do still have to remember, write your answer in scientific notation. So here I'd have to put the decimal here. So I went from here to there. If I was moving it 6 places going this direction, and I moved it 1 away from there, then now this would still be 3.4 times 10 to the 7th because it's still farther away. So you get your same answer however you do it. Good. Which is the largest number? Well, right off the bat, every single one of these numbers is going to give me a positive number. Even though this is negative, it just tells me it's a decimal. It's still positive. This negative is a negative number. Any negative number is smaller than any positive number, even a decimal with 50 zeros in it. If I have a negative number, it's smaller. So I know that's not largest. All right. Now I know that these two numbers have something in common. What are they? What's in common between those two? They have a positive exponent. That means they're going to be whole numbers. This number is going to be a decimal number. So obviously that's smaller. So that one's gone. All right, well, 4.5 is larger than 3.08, so is that the bigger number? No, because really what we would look at is the power. This is 10 to the 6th, which means I'm going to have more places than this. If I have a number that has more places, it's bigger, isn't it? Yeah. Just to prove it to you, 4.5, move it 5 places, so that'd be 4 zeros. 3.08, move it 6 places, so 4 zeros. Okay, so that's 450,000. And that's 3,080,000. So if you needed to, you would put them in standard form and check. So that one's bigger. Number 6, which of the following is not true? All right, well, let's just change these into equal. So this would be, well, let me do it over here. This would be 5.3, so I go over 1, so 2 zeros. And this would be what? So I'm just changing them into standard form. 1, 2, 3, and then 2 zeros. Right? I think so. So that's the same. Okay, so that one's not, that one is true. Okay, this would be if I moved it 2 places, 140. And if I divide it, that means I go back 2 places, right? 1, 2, what does that give me? 14. So that's not correct. Okay? So that's your 1. Got it on the second one. All right, number 7. If all the planets' masses were expressed using scientific notation, which planet listed would have the largest power? Well, first of all, you don't even need mathematics to do this. Use your science. What's the largest planet? Jupiter. Okay, now, if I needed to do it mathematically, like they just gave me some fictitious planets, I would need to make these all the same. For example, take this one. I need to move that decimal to put it in scientific notation, so I have to move it right there. Well, if I'm going 21 places this direction, but yet I moved it 1 place closer, now how many jumps would I do?
20.
How many?
20.
Just 20. There you go, so I have to adjust that. Okay, this one's already in scientific notation. So we can certainly compare these. Anything with a larger power is bigger, so I know that one's smaller than Venus. Okay, Earth, that's already in scientific notation. Uh-oh, they both have the same power. So now we look here. This one's bigger, right? So Earth is bigger than Venus. Okay, Mars. Okay, notice my decimal. I have to put the decimal right there. If that decimal from here is 21 places, now how many places will it be if I moved it 1 closer?
20.
Only 20 again. Good, you guys are getting the hang of it. Okay, but that power is less than Earth, so, whoops. So we know Earth is still bigger. Okay, let's do Jupiter. Well, look at Jupiter. I need to move this decimal back 2 places. So if I'm going 21 places right there, and I moved it 2 places away, now what would be the power? 23, because I went farther away. Notice right here is 21 places from this spot, but I moved it away, farther away. Okay, so that would be 23, which obviously is bigger than Earth, and in the end it'll be bigger than all of these. So that's proving it mathematically. Okay, number 8, the product of 800 and 300 expressed in scientific notation is. So we learned that you can change scientific notation to standard form or standard form to scientific notation. But you can also calculate with scientific notation. And it's very helpful when you multiply or divide big numbers. So, in this case, 800 and 300 aren't very big. We know product means multiply. So I'm just going to go ahead and multiply like normal. I mean, this is such a simple thing. That's 24, and there's 4 zeros. 240,000, but I need to write it in scientific notation, so I put my decimal right there, but that's where it was. So 2.4 times 10 to the 5th power. Number 9, what would the multiplication of 4,600,000 and 230 million look like written in scientific notation? Well, of course, we could multiply these two numbers together. On a calculator, if you have a large enough screen, it would work out. But the whole purpose of scientific notation is to be able to multiply or divide these large numbers without all the digits. So I'm not going to do that. I'm going to take this, and I'm going to change each of these into scientific notation. So this would be 4.6 times 10 to the, that's where my decimal is, so that would be 6 places. And I'm going to multiply that by, this would be 2.3 times 10 to the, would be 8 places. So in that lesson, back in about, sometime in November, on scientific notation, we know that we take numbers times numbers and powers times powers. Now I can take my 4.6 times my 2.3, do that multiplication. Okay, so it's not right, it's having a little trouble here. See if that's up, 10. Okay, I have 1, 2 decimal places, 1, 2 decimal places. Then when I multiply by powers, we know from the unit on roots and radicals that when I multiply a power with the same base, I simply add the exponent. Now, this looks good except for this decimal is not in the right place. I need to move the decimal back so it's between the 1 and the 0. Now, if I were to take this decimal and, like it says here, move it 14 places, what happens when I move it back a place? What happens to this 14? I'm actually getting farther away. So instead of 14 now, I have to move it 15 places. So that's my answer right there. Some calculators will take these two large numbers and multiply, and they'll give you the answer in scientific notation. Others won't. But we can do it by hand. Pretend if the number 0.00069 is written in the form 6.9 times 10 to the n, what is the value of n? Well, let's just change this into scientific notation. So I have this number. Okay, I'm going to have to put the decimal there, but this is where it was. So I'm going to have 6.9 times 10 to the, how many places to get it back? 4. But I'm going to the left because I know it was a decimal number. So that would be a negative, well, not negative, 14, negative 4. So what is the value of n? N in this case would have been negative 4. Number 11, 4 to the third times 4 to the fifth equals blank, expresses the power. Well, we just got done talking about that right here. When I take a power that has the same base and multiply, I just add the exponents. So 4 to the third times 4 to the fifth will be the 4 to the 3 plus 5, which is 4 to the 8th. You're going to get a lot more of this in algebra next year. They used a lot more of radicals and powers. Number 12, the distance of the Earth from the Sun expressed in scientific notation. Well, here's Earth, here's our distance. So We have 93 million miles. And I need to change that into scientific notation. I'm going to put the decimal there, so it's going to be 9.3 times 10. Well, this is where my decimal was, so how many places would that be? 7. And the last one, if 9 times 10 to the 8th is multiplied by 2 times 10 squared, the result expressed in scientific notation. Well, we just did that right here on this problem. Except for here, we had to change it to scientific notation first. At number 13, they already have it. So, remember what we're going to do? We're going to take and multiply the numbers times the numbers. So 9 times 2 is 18. And then the power times the power. So that's going to be 10 to the 10th. Now we just have to decide if that's in scientific notation. Look where the decimal is. Here's the decimal. We need to move it back there. So if it was 10 places going this direction, and I moved it farther away one place, now my exponent should be 10 to the 11th. So hopefully that helped you, and maybe you'll see some of these on the CRTs, and you'll go, hey, I know how to do it.